Hello guys, welcome back to In 5 Minutes. In this presentation we are going to see the multiplexer tree or how to use the lower order multiplexers to implement the higher order multiplexers, or also called as multiplexer cascaded structure. We are going to cascade two or more multiplexers to implement a higher logic. So before starting, let us try to understand one question according to which you will come to know how the multiplexer is designed or the multiplexer tree diagram is achieved. So implement 16 is to 1 mux, that is nothing but a higher order mux, using 8 is to 1 mux. Or they may ask you the same question. Let us suppose there is a function of 4 variables a, b, c, d, which is of sum of product form, and the variables are 0, 2, 4, 6, 8, 12, 14, 15. So you may see that there are 16 combinations, so there will be 4 variables, so we need 16 is to 1 mux. But the question is like that the function and implement using 8 is to 1 mux. Since you know that these are 4 variable functions, to implement this in the normal multiplexer structure you will be required 16 input is to 1 output, that is nothing but 16 is to 1 mux. But the question is asked in a reverse order. The question is asked like solve this question using 8 is to 1 or 4 is to 1 mux. So how you will solve it? So before starting to this, what we need 16 input lines and 1 output lines with the help of 8 input and 1 output. So definitely I will be requiring 2 8 is to 1 mux. So I have drawn 2 8 is to 1 mux, so I will name that 8 is to 1 mux, 8 is to 1 mux. Means what? This multiplexer is going to have input lines I0 to I7. So I will name that D0, data line D0 to D7. I will name them I8 to I15, that is nothing but D8 all the way to D15. Now there are 3 select lines S0, S1, S2 and S0, S1, S2. So these 3 select lines I will use in the same order, so I will combine them. So what I have here is, so these are my inputs. But to implement 16 is to 1 mux, so you can see that I have 16 data input lines D0 to D15. To control this I will be requiring 4 variables. So out of 3 I am getting here, and what I have here is the output y1 and y2. These are the output section, and I will combine them with the OR gate. So the final output will be, that is nothing but implementation of 16 is to 1 mux using 8 is to 1 mux. So this will be final output. I will name it as y. Now how to use the 4th variable? Since 3 variables are used, now be careful that I have not mentioned yet what is the MSB and what is going to be the LSB. So first of all I will name it MSB LSB. So let me say A is the MSB bit and D is the LSB bit, out of which what these 3 bits are I have not decided yet. But you will see carefully, if I implement 16 is to 1 mux, suppose A is the MSB, so for the first 8 combinations, that is nothing but I0 to I7 or the data D0 to D7, A bit is going to be at 0. So what I can do here, I can use the enable pin, which is logic low. In this particular design I am using logic low enable pin. So this is E1 and E2. So once again I need to mention here while designing this kind of problem that active low enable is used. You may also use active high enable. I am using active low enable. So what I can do, I can use A bit. So I'll name A bit here. So I can use A bit directly connected to this E1. For the first 8 combination this IC will be activated, and I will use one NOT gate here to deactivate this IC. Means what? Whenever A will be 0, this will be 1, and the IC 8 is to 1 mux 1, which is containing D0 to D7 data lines. So 1 will be activated when I is equal to 0. At the same time this 0 will become 1 due to this inverter gate, and this active will be deactivated. So I can use my BCD bit as here, bit A, B, C and D. BCD will be always there to select the lines. So if BCD 0 0 0, then 2 inputs will be selected, I0 and I8, but A bit is MSB, that is most significant bit, which will decide whether to select I0 or I8. If A is equal to 0, so it will correspond to I0, so it will select the first mux, and if A is equal to 1, I8 input is selected according to the decimal equivalent of ABCD, that is input A1 BCD 000, and the function is achieved. You need to write down MSB and LSB part here also, so I'll mention beside A it is MSB and towards D it is LSB, and the function is to be implemented in like this way.